Hello, hi all. My name is Sadish Kumar. I am EC student at Jaya Engineering College in Chennai. This is my first internship, and I learned lots of concepts in this internship. I gained more technical skills in this internship. Thanks for giving this opportunity, and this internship very helpful for my career. And the course is embedded system internship, and provided by Emertxe. And below the concepts are involved this internship. And first C modules, embedded system overview, project verifiers also, and LED and melody programming, matrix keypad, CLCD, timer and interrupts, and project implementation. And this internship involves various concepts and also test and assignment, weekly test, assignments and live interaction also available, and the weekly test, evaluation, project implementation. And next slide is uh, intro of C. C is a high-level programming language widely used for system programming and a low-level hardware interaction. And embedded system, C provides direct hardware access, efficient memory usage, and real-time performance, making it ideal for firmware development. I learned lots of C concepts in this internship, and it's more helpful. And first is data types. Various data types are available: the float, integer, character, string, and more, etc. The size of data types, characters, and integers 2 byte and 4 byte. The long int is 8 byte. Long int is 16 byte, and character is 2 byte. The primary function of the C is print and scanf functions. Printf is display the output of the code, and scanf is get the input of user. And next we see this PC conditional statements. Conditional statement as if and switch, while, do while, and for loops. First, if condition, the if is condition is satisfied, print the execute the inside the code of condition. And condition is not satisfied, it is executed the else condition. And this is the if black. And next go to the switch. Switch is declared as the structure, and the explanation inside the switch condition. First, case 1 is satisfied, the code is executed inside the case 1, and case 2 is also executed inside the code inside the case 2. And this condition is not satisfied, its default condition is executed. Next go to the while condition. While loop is declared as the structure, and condition is satisfied, this code is executed inside the while loop. While loop is also called as a infinite loop. To do next control statement is a do while. First execute the inside the do, and next go to the while. The condition is satisfied, the execute the while loop. The condition is not satisfied, the code is break. Next go to the for loop. For loop is this structure, and first initialize the variable, and next the conditional, and next increment operator. The for loop is executed until the condition is satisfied. It's executed inside the for loop. These are all the conditional statements. In various conditional statements, I learned this internship, very helpful. And next go to the operators in C. Operators in C also learned in this internship. And operators are 5 operators. First, arithmetic operators, and logical operator, next relational and assignment operators, also bitwise operator. Arithmetic operators plus addition and subtraction, division, modulus, power, Logical operator is logical and logical or not. Relational operator also double equal to equal and less than, greater than, not equal to also. This is assignment operator and bitwise operator also. Next, array and pointers also learned in this internship. Jayalakshmi Dhananjay ma'am is teaching is very well. Then and this is array. Is collection of elements in the same data type stored in the contiguous memory location. It allows easy access and manipulation of multiple values in single variable and index. This is the syntax of array. First, the data type, what data type you want, and int and the character, anything. This is the array name. str is the array name. The size of array, 5 elements only stored in this array. A, B, C, D, E. 0 position, first and second, third, fourth. Final is null operators used. Next, pointers is used for the store the memory address of variable. Pointer is declared as first data type, and next the variable of pointer. Example program is int a equal 10. str is the pointer variable. He store the a memory address. So printf used to printf display the what type of values in the str. And the next printf statement, what values inside the pointer variable. This is the array and pointers. Next, go to the strings and the macros. First, string is an array of characters ending with null character used to store a manipulated text. Macro also a header file. Macro is embedded system preprocessed directive that replaces code before compilation, optimizing performance and reducing memory usage. Next part is intro of embedded system. What is embedded system? Embedded system is simple word, both hardware and software. Embedded system is specialized computing system designed to perform dedicated functions with larger system after real-time constraints. It combines hardware and software, typically used using microcontrollers or microprocessors. Example of embedded system: automatic braking system also, and washing machine, air conditioner, refrigerator, TV, television also. Embedded application of embedded system. These are all the. And next, peripherals. What peripherals are used for the implement the project? This peripherals used to. First, switches also important primary peripheral of the embedded system. Embedded system acts as a user input or control signals, enabling interaction with the system by toggling states. They are used in keypads or mode selection and power control, often interfaced with the microcontroller for pre-processing. Two triggering are available in the switches. One is edge triggering, low or high or falling high to low edges. Level triggering responds to a constant signal state, remaining active as long the input states high or low. Level triggering is once pressed is continuously executed, and edge triggering is only one time press. These are the switches functions. And next, matrix keypad. It's a peripheral used to embedded system for user input, consisting row and columns, forming a grid of switches. It reduces the number of GPIO pins required by using scanning technique to detect the key press efficiently. It is used for efficient. It is 4 rows and 3 columns. And Next, go to the CLCD. CLCD also one of the peripheral of embedded system. CLCD is a display module used to embedded system to show text-based information commonly interfaced with the microcontrollers. It have various modes and types. The various types is 16 into 2 cross LED LCD and 16 into 4 cross LCC LCD are in the embedded system peripherals. Next, timer and interrupts. The timer is one of the inside peripheral. Timer in a microcontroller hardware module that counts the clock pulse to measure time intervals or generate precision delays. It can operate different modes like delay generation, event counting. Timer is one of the primary peripheral of the microcontroller because it is count the clock pulse or tick the delays. Next, interrupt. Interrupt in a microcontroller signal that temporarily halt the main program to execute a specific task, then resumes the normal execution. Enable real-time response to external or internal event like sensor inputs, timer overflows, or communication signals. Interrupt is once current program interrupt is enabled, the current program is stop and the interrupt function is enabled. The timer is once the timer is enabled, start the tick up to 250. The ticking period, the time period is 1 second for complete one cycle. These are the timers and interrupts. These all peripherals and embedded system various C models are helped to involved in this internship. Next final is project requirements, project development. Once the project development is project name is micro oven and the peripherals we need, and first is CLCD, the matrix keypad, buzzer, fan. These are the requirement of project. Next, go to the project details and black diagram of the project. This is the project and Emertxe. Project name is micro oven. First, the requirements of the project. This is the black diagram of the project and microcontroller, and this is the input of the project display. CLCD, matrix keypad also input, and fan is the output, buzzer is also output. This is the project requirements of the project. This is the requirements, and go to the project code. First, what peripherals we need, and first is matrix keypad. The matrix keypad, this is macro file of matrix keypad. This is the column data port, and the column port is declared as tris B, and row port is declared tris D. The row pins, and row 1 is RD2, RD3, row 2 is RD2, row 3 is RD1, I is RD0. This is the column pin RB1, RB2, RB3. Next, the high and the low, 1 is 0, state also 1 and 0. All released is FF, hexadecimal FF, and function of this project, function of matrix keypad, read matrix keypad, and the initial matrix keypad void function. Next, the CLCD. The next is source file of matrix keypad. This is the matrix keypad C file. This is the header file of matrix keypad. This is the macro file of matrix keypad, and initialization of input output ports. This is the column port declared as first is this seven pins, and matrix row port, and this is declared as hexadecimal. This AND function, it is R the output selection, and NBRBP was the enabling port pull-ups. Next, main code of the matrix keypad. Initially, row pins are declared a high. Next, we come to the function of read matrix keypad, and static unsigned CAD as and initially once equal to 1, and the next variable is key equal to scan keypad. To go to the scan keypad function, and the scan keypad is there. Initially see int I, the variable is I. First the initialize row 1 equal to low, and row 2 high, and row 3 row 4 high. This is the for loop. Once the column is low, return 1. If else column is 2 also low, return 2. Else if column 3 equal to 0 low, return 3. Next condition is row 1 equal to high, row 2 equal to low, and row 1, 3, 4 also high. The for loop is execute until 100, and if column 1 is low, return 4. Else if column 2 is low, return 5. Else if column 3 is equal to low, they return 6. Next condition is only row 3 is equal to low, other condition also high. If column 1 is equal to low, return 7. Else if column 2 equal to low, return 8, and else if column 3 equal to low, 3 equal to low, return 9. Next condition is only if row 4 is equal to low, other condition is high. If column 1 is equal to low, return star, and else if column equal to low, return 0. Else if column 3 equal to low, return hash, and otherwise no one is pressed, it's written all released. This is the function of matrix keypad. And if mode equal to low, return key, and else this condition is not satisfied, else condition is executed. If key not equal to all released, and once logical and once equal to 0, return key, and else if key equal to all released, once equal to 1. Next, go to the CLCD hatch file. This is a CLCD. CLCD is one of the peripheral. This is the macro file of CLCD. Initially define the frequency of CLCD is 20 MHz. This is the data port of CLCD. Is tris D is the RS pin of CLCD, tris E, and the enable pin of CLCD is tris E1. E2 is E1. Like same thing, and port D RE1, RE2. Next, the instruction mode of CLCD. Instruction mode is like cursor move, and otherwise instruct the CLCD. Data mode is also known as print the CLCD. Nothing one, and it is 1 0. This is 1, and bar is like this. We need bar, so the hexadecimal code for bar is FF, and I equal to 1, low equal to 0 also. And this is the CLCD is 4 line matrix, 16 into 4. So line 1, line 2, line 3, line 4. This is the CLCD of. This is address of CLCD. Line 1 address hexadecimal code is 80. Line 2 address is C0. Line 3 address is 90. Line 4 address is D0. Next we see the after later. This is the 8-bit mode. It or enable this code is enabled for enable 8-bit mode. This code is this value is enabled 4-bit mode. The same thing, 28 2 lines and a clear display screen and a display on cursor of. This is the value of these functions. Next the initial. This is a function, init function for the input output declaration, and CLCD put ch for is print the character of CLCD for used. This function is used to print the character in CLCD. Next CLCD print used to string, and otherwise the sentence or print used to CLCD. This function is used to print the string functions are used in the CLCD. Next CLCD write. CLCD write is used to all characters and the strings write to the sent to the CLCD this format. This is a CLCD function, and next the main code of the micro one project. And first and next we see timer macro file is this id init timer 2. We take the timer 2 for perfect time counting. This is the main C file of the timer, and the main header file and a timer macro file is the initialization of timer 2. These values were assigned to enable the timer 2 PR to 250 to until this timer 2 count the tick, take the tick until 250 till 250 ticks. This is the interrupt function. This is the main header file of the ISR, and the next is the main macro file of main and macro file of micro 1. These are the variables used in the void ISR function. We see in later the ISR function. We see the main code of the micro 1 project, and this is the header file of micro 1. This is the main header file of main C function. This is the CLCD macro file, and this is main macro file, and this is micro 1 macro file, matrix keypad timer. The function this condition is watchdog timer off. Next the initialize the input output of the micro 1 project. Initialize the CLCD and the initialization of matrix keypad function, and this is fan pin is declared output, fan is initialized turned off. This is the config the buzzer port. It is declared as output, buzzer is initialized turned off. This function is timer 2 function. This is initialization. This is the flag to interrupt functions. The variable is initialized declared unsigned char. The variable operational flag is initialized declared the power on screen, and variable key and the reset flag is equal to reset nothing. We see later. The main code, the initialize the output port for the micro 1 and output input and output for port initialization config. So while loop, this is while loop until this is infinite loop, like the condition is true, always true. And we came to the if condition. Operation flag is menu screen, but the operation flag is power on screen, so this condition is not satisfied. Go to the next. This is not satisfied, and go to the switch. So operation flag is power on screen, so came to the switch function. The condition is satisfied, power on screen is satisfied, so executed in the case 1 power on screen function. We go to the power on screen function. This is main micro 1c code. The micro 1c code, main header file, and micro 1 macros LCD matrix also. This extend unsigned char operational flag. This is for once we declared a variable in the main code. So next we assign the extend the variable in this next function file. So void power on screen, the function is executed. First for loop unsigned int I equal to 0. This is condition of for loop. The for loop is executed until 16 is increment operator, increment condition. So the code is clcd put ch. The bar is print until 16 position, like this, and clcd print power on screen and line the power on screen. The data is sent and line to the second position, and clcd print micro 1 line 3 first position, like this, power on screen and micro 1. For next we for loop unsigned int, this is like same like this, and clcd put ch. The bar is printed the line 4. This is line 1, the line 4, like this. First line 1, the line 4 of the project, and delay of the function, and came to the main code. And the next operation flag class assigned menu screen. We go to the menu screen, and so while next the while loop, if operational flag is equal to menu screen, and it came to the if condition, key equal to read matrix keypad. This is the input of the key. If key pressed, key equal to 1, press key equal to 1. No. Power on screen, the operation flag is the menu screen. And the next condition, case 2 is menu screen. The operation flag is menu screen, so menu screen function is executed. We go to the micro 1c and come to menu screen function. This is the menu screen. clcd print first the option of mode of the projects, like this first micro mode and grill and convection key, and next start. This is the functions. First the clcd print for the first one is micro line 1 and 0 position print, to second position mode is to grill, the third is convection and start. And clear screen, this is the clear screen function. The clear screen is it is display clear screen function. Next came to the main function while loop. The operational flag is menu screen. Same time main screen also executed. The once key one is pressed, the operational flag has a micro mode. Else key 2 is pressed, this is the working the grill mode. And else if key equal to 3 is pressed, this is the reset mode, convection mode. Else key 4 is pressed, it is the start mode. The power on screen and the menu screen and micro mode. Once micro mode is operational flag is declared, assigned the micro mode. We came to the micro mode, the function of set time key and the set flag, reset flag. Once the key 1 is pressed, the reset flag is equal to reset mode. The initially reset flag is assigned to the reset nothing, and once the reset flag is assigned reset mode, we get to the set time function in the micro 1c. We came to the micro 1c, and this is the set time function, and the variable is key and the reset flag. The static unsigned char is the two variables blink position and the key count. If reset flag is reset mode, the blink position is also 0, seconds and minutes also 0, key count equal to 0, key also all released, and reset flag is reset nothing. And initially is in this CLCD print set time and the minutes and the seconds line 1, and print a time and clear. This all the exit and the CLCD. Next, the key for the enter the values in the minutes and the seconds. The if condition is key is not equal to star and logical, and the key not equal to hash and logical, and key not equal to all release. The condition is satisfied, execute the inside the key if condition. The key equal to key count is increment, and if key count is this condition is executed until reach the condition satisfied. And second is the print press the 1 and add this code. Else if the count is condition is not satisfied, they execute the else if condition. And once if you assign the values of minutes and seconds, come to the this is the key equal to star. This is used for reset the minutes and the second values, and star ash is turned on the fan and turn off start the mode of the for micro mode. Clear screen, turn on the timer function, interrupt function. This is the interrupt, and this condition is satisfied. The count to 20,000 nanosecond 200 nanoseconds until this condition is executed 1 second. If second is not equal to 0, second is minus. If second is equal to 0, logical and minus is not equal to 0. So minutes equal to minus, and same repeat second equal to 60. And come to the micro 1c. The operation flag is a display time. We go to the display time in the main function. display time. Where is display time is come to display time, the function is executed. Go to the my display time. The blink position equal to 0, the blink is the first position and the blink position is equal to 1, and the condition is not satisfied. They saying blink the 6th and 7th position of the CLCD. This is used to set the like this, and this next is the code, display time code, and CLCD print. This is the time, and CLCD put CH. This is first of the second spot. This is the semicolon part. This CLCD put min is divided 10 plus 0. The 0 for the convert the integer decimal value to character ASCII value, and next the mode is shown the code. Next part, the mode, the output of micro and build, clean and build. The code is built successfully. Next, come to the so once Vixim lab, this clock is as 20 Hz, and choose the 16 into 4. Next, go to the load X of file, the Pixim lab, load X. Micro one open, micro one on, micro one power on, micro one. Now choose the first mode, power 9500 watts. And the first set time, once click the 1 and 2 and 3, 4. Once they click the set time and start the enter button, start the mode. It start the mode. It take the count timer function and start and pause, stop the pause, 5 equal to pause, pause, 4 equal to start, 4 is start option, 5 is pause, and 6 is stop. So stop, and so next the enter the select the grill mode and press the 2 button, and press second grill mode. So grill mode is on, and enter the time for grill mode. So enter the grill mode in seconds and minutes, and start the grill mode. So start the grill mode. Same the micro mode. No change. And fifth button is stop. Pause. Press the pause. And start is the fourth button. And number 6 is stop. So grill mode is completed, and the third is convection mode. Choose the convection mode and set the temperature and to 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 and press the 2 and enter the set temperature. Enter button. Press enter button. They execute the preheating button. Timer is not working. The code recheck and clean and build. Sometimes the bug in the Pixim lab. So reload the X file inside the load. Open. Powering on. And final one is third one, convection mode. Convection mode is set the temperature and press to set up and enter button. Turn on the convection mode. Test is working. The preheating section is working. The remaining time is 56 seconds. And next 54. We wait until it reaches 0. The next mode is start mode. The micro have four modes. The final mode is start mode. The breeding session is finish, end up soon. This is the final page. So enter the time period to the convection mode was start once end. This is the same micro mode concepts. So stop and final mode is start mode. Start mode is once you press the start mode, its time is count to 30 to 0 reaches 0. So enter the fourth start button. It's add the current time to 30 plus 30, and also pause and start, and finally stop.